Good morning, good evening, good afternoon. This is Doc Pete, and we're going to deal today with fractions. And guess what? We know that this is going to come up on some of your word problems, so a little birdie told us to go ahead and do this. I was instructed that this might be something that would help you. First of all, if I give you two numbers, just say 1/8 and 1/2. Which is the greater number? 1/8 or 1/2? Well, you've got 8 in that number. The first thing that most people say, oh, the 1/8 is larger. But if you divide 8 into 1 and divide the 2 into the 1, you're going to get a big surprise. Because the 8 is larger and it's in the denominator, as an expression in mathematics, it doesn't matter what the larger number exists if it's in the denominator. The denominator really will determine the value of the expression. Expression being anything that you write that doesn't have an equal sign or greater than or equal to or whatever. You understand what I'm saying? So the top number is called the numerator. The bottom number is called the denominator. And incidentally, parenthetically, you can stop this video when you want to by just pressing pause. If you want to look at that, the spellings, etc., go back it up, and you can look at this again. So don't get fooled by that. You may have some problems that exist that will be given you. You have to read them first. That's why it's very important to continue to read, because if you're not reading well, guess what? You're going to have a problem with this GED or whatever test that you take. You have to digest the information that they give you, every piece of information they give you, and we'll deal with some of those word problems later, dealing with fractions. But for right now, we just need you to know, the more you practice this, the better you're going to get, just like everything. Do it daily. Do it before you eat. Do it after you eat. Do it before you go to bed, and I think you'll have it pretty much solved by then. As many times as you eat, you practice your fractions and practice your mathematics. And I say this also parenthetically. Know every product, meaning times, 1 times 1 up to 9 times 9. And actually you should know what 12 times 12 is, 12 times 11, 12 times 10, come on down to 12 times 9. And the same thing for 11. But I'd be real happy if I see you at church or whatever, and I ask you what 7 times 8 is, and you come up with the answer real quick. I'll know you've been practicing, and I know your parents have been working with you, so, you know, or whoever, somebody's been working with you to know that what this is. You have to know what that is, but then you have to know backwards. What is 72 divided by 8? You have to know some of these that I know are difficult, but again, it's going to help you with your fractions. It's going to help you get a real good concept in terms of three-dimensional of what the universe that God made through his son, Jesus Christ. Yeah, that's what I said. Jesus Christ was the creator. And you can kind of wrap your brain around some of the things that were made in creation, especially the you future architects, etc., who need to have a 3D perspective, and especially geometry under your belt and trigonometry. And we'll deal with those subjects later. In any event, we're going to deal with another aspect. Improper fractions are those that are not reduced, like 2/4. What's the biggest number that'll go into the 2 and the 4 to reduce this fraction? Of course, it's 2. So that 2/4 ends up being 1/2. You don't have to find the least common denominator or anything like this until you start adding your fractions, and we may deal with a problem like that later, but I think we will. So let's go ahead and go to one of those problems, an improper fraction, because actually a number that like this, 7/4, is an improper fraction too. What does that equal? 7/4, you divide the 4 into the 7, and you get 1 3/4. So let's just go, let's just say a lady had 7 children. One household had 7 children, decided to build some, decided to make some pies together. So one lady had 7 children, and she and her husband. Another lady had 11 children, okay? And they each were given a quarter of a pie. How many total pies were necessary to be made? So they each got a quarter piece of a pie. Okay, so how many pies total? If they got together, how many pies would they have to make? And that's a typical word problem. Okay, so if you deal with the first one, the first family had 7 children, so we deal with 7 children who got a quarter. And then we get another one that had, what did I say, 11 children who got a quarter. And totally, guess what? Now let me mix this up a little bit. Because the lady who had 11 children, the lady and the man who had 11 children, they only gave their children an eighth. Yes, they didn't. The second family had to divide those pies up a couple times. How many total pies would have to be made if they made them together? And of course, they didn't show each people getting their piece of the pie. We just had to give them the pies and move forward. Okay, so let's look at this. 7 over 4 is the same thing as 1 3/4. Okay? That number there. Okay? 11/8 is the same thing as 1 3/8. How about that? We picked a good number. So again, is 3/4 bigger than 3/8? The same thing we asked you on the 1/2 and 1/8. Is 3/4 smaller than 3/8? Because you got a big number in the bottom. Oh, so your denominator, your numerator being on top, and your denominator being on the bottom, you did consider that little dilemma this time, and it's something you should consider. Because if you have an eighth, you're getting a smaller piece of pie than you were if you got a quarter. And let's just show you how that looks. And of course, this is very crude on this drawing. I mean, very crude. It's so crude, I'm going to have to start it over. And we'll deal with it. But let's deal with this fraction here first that we're talking about. And adding these fractions to determine how many pies. So you know you're going to have at least 2 pies that are needed. You add the 1 and the 1, and you get 2. But that's not the way we do fractions. We deal with the fractions first and find the least common denominator between the 3/4 and the 3/8. Okay? Because we know they're not equal. You just can't add 3/4 and 3/8. It just doesn't work. So looks like that the biggest number that will be going to both of them, or that allow both of them to go into, will be 8. So you change the 3/4 to 8. Do you divide the 4 into the 8 and get what? 2. And then 2 times 3 is 6. 6/8 is the same as 3/4. You don't need to mess with the 3/8. So you deal with 3 and 6 and add the top numbers, meaning the numerators. I know we're taught that you need to stay on top, but guess what? What's on the bottom is what counts, okay? Trust me, and that goes for building and other things too. If you add your 3 and your 6, you're going to get 9/8. And of course, that's an improper fraction. You've already added your 1 and 1 and got 2. And so 9/8 is the same thing as 1 and 1/8. You add that 1 to your 2 and you get 3 and 1/8. Well, can you make 3 and 1/8 pie? No. You might as well go ahead and make 4 pies. And guess what? One family gets 2 pies. Another one gets 2. Let's see here. 2. It gets 4 altogether. So another family gets 2 pies. And of course, they're only going to need 1 and 1/8 of their pie. Actually, they're going to need. Oh, wait a minute. I'm making an error here. If you have 1 3/4 pies right there, you've got 2 pies right there. If you've got 1 3/8 pies, you got 2 pies too. So you could have found it out like that. But to do it proper, you have to know what kind of fractions you have. And of course, the total number of pies that are needed are 4 pies. We determined that already. one family gets 2 pies, the other family gets 2 pies, except one family has to divide theirs into eighths. So they take the fourths and they divide those into 2. This is one family gets the 2 of these and they divide them into fourths. The other family gets 2 of these and they have to divide theirs up like this. Maybe there'll be enough left over for the parents. And of course 1/4 and 1/8 are drastically different, and especially when you talk about 3/4, it ends up being a little bit closer, a little bit bigger, because the numerator is 3 to both of those. So again, that will conclude this lesson. I hope we didn't confuse you with all that rigmarole, but again, we knew we had to have 2 pies for each of them, and hopefully you can practice this at home and stop the tape and ask me questions as you see me in the hallway. And we thank you, we love you, and ain't nothing you can do about it.